Hello everyone and welcome to today's webinar on integrating alternative fueled vehicles in oil and gas facilities. My name is Amy and I'll do a brief introduction to this webinar and help moderate the Q&A session later. So just a bit of webinar housekeeping. This webinar is being recorded, as you just heard, and will be made available on YouTube in due course. All participants are muted, but we do want this to be an interactive session, so please post questions in the Q&A function and they'll be answered at the end. So I'm just going to quickly introduce the Energy Institute for those who haven't heard or worked with us before. So the Energy Institute is a professional body for the global energy industry, delivering good practice, knowledge and training across a wide range of topics and for a wide range of resources. These resources include good practice, events and training. And to find out more, please visit the Energy Institute website. And if you are not a member already, again, please feel free to check out the website and see what we have to offer. We also have a new associate membership scheme, and you can see some of the benefits of this on screen. And to find out more about this scheme, please feel free to contact membership@energyinst.org. So the Technical and Innovation Programme produces good practice guidance, and this is developed by committees made up of subject matter specialists. There are 30+ projects commissioned each year and hundreds of published documents on the Energy Institute publication site. The publications vary from aviation to environment, as well as many other topics. And then finally, the Energy Institute have a new platform that we have recently launched, which is for members from across industry and across the world to interact with each other, called EI Together. With EI Together, you can access insights from leading experts in the energy sector, participate in topical energy discussions, and build relationships whilst networking. So if you are a member of the Energy Institute already, please feel free to check out this site. I'm now going to pass over to my colleague Jamie, who will contextualise why we're here today, and I'm going to stop sharing my screen.
Good afternoon, everybody, and thanks for joining today. And also thanks to Amy for organising this webinar, which is really appreciated. As Amy said, my name is Jamie Walker, and I am the Energy Institute's technical specialist for the energy infrastructure and downstream committees. So basically, we look after everything from leaving a refinery through to going through the pumps at filling stations. The committees we look after are the overarching committee, the road tanker panel, and also the service station panel. And we also provide secretariat information to the Petroleum Enforcement Liaison Group, which are the regulators of the filling stations, predominantly trading standards, environmental health people. My background, I've spent 35 years of my working life in logistics, the last 18 of which have been in the fuel industry. I was a terminal manager for Merco Petroleum before moving to be the Director of Health and Safety at the UK Petroleum Industry Association, and then finally setting up as a technical consultant where I look after the work, as I mentioned, for the Energy Institute and also for the Downstream Fuel Distribution Forum, the Petroleum Driver Passport, the Safe Load Pass Scheme. And for my sins, I also get to travel 8,000 miles to the South Atlantic to look after the health and safety of the fuel terminal and the filling station on the Falkland Islands, which currently, despite our 32 degrees here, is currently sat at -1 degrees with 2 inches of snow on the floor. So if I can share my screen now, bear with me 1 second. You should now be able to see.
Yes, we see that.
Can everybody see that okay? Yeah. Okay. So as I mentioned, I spent 8 years of my life as a terminal manager at Merco Petroleum. And one of the constant challenges we had, or not challenges, but one of the constant issues that we faced was contractors coming onto site, making sure that their diesel vehicles, which at the time it was purely diesel vehicles, were equipped with Chalwin valves, spark arresters and anything else similar. Which was great. We kind of got round those issues, no problem. But the UK oil and gas sector is now committed to supporting the DEFRA Clean Air strategy and the Department of Transport's Road to Zero policy. As I mentioned before, we previously allow routine non-permitted access by diesel fuel vehicles, but the transport strategy now includes the increased use of ultra-low emission vehicles. And these vehicles, as well as the tailwind hazards and all of that kind of stuff that we mentioned previously, may introduce additional hazards. And it's really important that designers of the vehicles, the vehicle operators, and also the facilities themselves consider whether and how these vehicles can safely access site. To work with this, the Fuels Infrastructure Distribution Committee in 2019 highlighted the need to develop some new industry guidance regarding the hazards on these other alternative fueled vehicles. And crikey, it seems 5 years ago. Wow, that time really has flown. The working group was set up to include the oil and gas companies, industry bodies, and also vehicle manufacturers, because we wanted to get the whole picture. We needed to capture the hazards that we faced at the terminals and also the potential hazards that could come on board with these new vehicles. So we pulled together the existing knowledge that we had rather than carry out complete new modelling, because by pulling all of those people together into a working group, we felt that we already had the knowledge and the resources to put together the research document we were looking at. The scope of the document rather, was to the following alternative powered vehicles. So LNG, CNG, electric, petrol, hybrid, LPG, hydrogen combustion, and also hydrogen fuel cells. I should stress here that this only addresses recently manufactured vehicles. It doesn't address older designs or aftermarket conversions, because we felt this was a very generic business, that obviously the aftermarket conversions and all that kind of stuff, and life cycles on vehicles on plants aren't particularly high, and we felt that by the time the guidance came in, then most of the older vehicles would be kind of taken off the market and new vehicles would be coming in. The application really is aimed at refineries, terminals, storage sites, and other oil and gas facility operations. So it might be kind of boosting stations along the way of a pipeline and that kind of stuff as well. And the target audience we aimed at were obviously the oil and gas facility personnel, similar to myself in previous iterations, and engineers as well, and also haulage companies that work within the oil and gas facilities. We know that HGVs aren't that prevalent when it comes to loading facilities at the moment, but the potential will be there for them in the future. Contractors, vehicles working within oil and gas facilities. So we may have kind of tank cleaning companies coming in, tank repair companies, all of that kind of stuff. And also the vehicle manufacturers and suppliers themselves who are providing the vehicles to the above. We split the project down into 3 phases. Phases 2 and 3 weren't given the go-ahead until phase 1 had been completed, and we knew that there was more work to do with the 2nd and 3rd phases. So phase 1 really looked at a review of the hazards and also the risks associated with the alternative fuel vehicles. And then, as I say, phases 2 and 3 really came along afterwards to identify and kind of mitigate against the key risks posed by those vehicles. We split it down into 2 sections. The LNG, CNG, LPG and hydrogen combustion we did first, because we felt that that was kind of, the knowledge was already there for those powertrains. Whereas with some of the stuff in phase 3, the EVs and also the hydrogen fuel cell vehicles, they were still evolving, and we wanted to give kind of the work another year before we moved on to those, and also to spread the cost to give us a better document in phases 2 and 3 as well. So if we go back to phase 1 now, I should just stress that this only considers the key hazards associated with the powertrain of the vehicle type, including the power source and the storage, i.e. the batteries on EVs, that kind of thing. It does not include any peripheral equipment such as reversing cameras, new technologies that are being put onto vehicles to kind of mitigate blind spots and all of that kind of stuff. And it certainly doesn't consider impacts to the environment, whether they be positive or negative, because again, that kind of work is picked up within other areas of the Energy Institute as well. So the approach, we looked at basically the actual risk levels which differ for each site and are impacted by issues such as the number of vehicles on site, the proximity of personnel, and other products that are present on the site. For instance, we might be looking at a refinery, which is quite a complex operation and has lots of products around, lots of hazards. Or we might be looking at a smaller site that maybe only stores 40,000 litres of diesel, which is relatively low hazard compared to some of the other products that we see within our facilities. So therefore, the risks that we considered were in comparison to the diesel-powered vehicles that we currently see within our facilities themselves. And the other assumptions that obviously we looked at were, this includes a temperate climate, so the climate that we operate in here in the UK, and there being no maintenance, refueling or charging of these vehicles on the site. So all of that kind of work is done off-site, maintenance in particular. We expect the vehicles to come onto our facilities in a well-maintained condition. We then looked at, and this is probably the most important part of the initial piece of work, 13 hazards which we considered in comparison to a diesel vehicle. Those being powertrain sparks, powertrain high surface temperatures, powertrain fires, ignited releases from the vehicle fuel system, rupture of the fuel storage due to external heat, high pressure fuel releases, low temperature fuel releases, rapid expansion of fuel releases, toxicity and asphyxiation, fuel compatibility, electric shocks from the powertrain, quiet vehicle running, and powertrain runaway. So those 13 hazards are all looked at for the various ignition powertrains that we looked at earlier on. The guidance layout is identical across all three phases. So we have separate sections for each of the alternative fueled vehicle types, and then separate subsections within each of those for each hazard, showing the initiating event, a description of what the event could lead to, the severity of the consequences associated with the event. Please note that that is in comparison to the diesel vehicles and the consequences from that, and also how likely the identified consequences will occur, again in comparison to diesel powered vehicles. So if we take an example now, we'll look at the comparative risk example of low temperature releases of LNG compared to diesel. The initiating event is obviously the low temperature release of the LNG. So we look at a low temperature release of LNG from the vehicle's fuel system. Please note, this is only the vehicle's fuel system. We're not considering what products the vehicle is containing. It's just the fuel system and the impact that may have on personnel or equipment. So the hazards from the low temperature release are obviously LNG is stored at extremely low cryogenic temperatures, around about -132 degrees C. And if there is an unignited release of LNG from the vehicle, either from the relief valves within the fuel system or from a damaged fuel system itself, then this could lead to personnel who come into contact with the release receiving cryogenic burns from the property. In addition, if cryogenic LNG releases were to impinge on equipment, then this could also result in brittle fractures occurring. We then looked at the consequences, and in the event of an extended exposure, obviously personnel could receive cryogenic burns requiring hospital treatment, lost time injuries, or even in worst cases, permanent disabilities, while equipment itself could suffer from the brittle fractures we mentioned earlier. Releases of diesel from diesel-powered vehicles would be at ambient temperature, and as such would not result in any cryogenic impact. So again, we're comparing the LNG with the diesel. So therefore, it's considered from the comparative severity of a low temperature release of LNG that it would be much more severe than for diesel-powered vehicles. And you'll see from the small grid below that, that low temperature releases obviously are not credible for DERV, but they are more credible for LNG. So moving along the line from green towards red, we've kind of put this into the yellow to between yellow and amber kind of category. We then moved on to looking at the likelihood of this happening. So it's assumed that there will not be LNG refueling on site. So therefore the LNG will remain containerized within the vehicle unless there is a release from a relief valve or damage / failure of the LNG tank and its associated equipment. The likelihood of a release of natural gas from an LNG powered vehicle from the relief valve rather, really depends on how likely the pressure within the system exceeds the set point. And this is impacted by several factors such as the engine design, how recently the vehicle has been used, how full the fuel tank is, ambient temperatures and that kind of thing. So as such, it is credible that the relief valve can be activated within the terminal area, resulting in a release of natural gas. However, it is extremely likely that the valve will only be activated for a short duration until the pressure has been relieved, which obviously reduces the likelihood of personnel being impacted by the release. The LNG or the associated tank could also be damaged / fail, causing a release. However, the more likely time for this to occur is while the vehicle is off-site, partly due because the most proportion of time is spent on-site, but also things like slow speed maneuvering is kind of much more controlled on a facility. So the likelihood of a road traffic collision or something similar is mitigated because the harsher driving conditions, we don't experience those on the site. This could, however, result in a longer duration release if it did happen, although the likelihood, as we mentioned, of a release from a damaged / failed fuel system occurring is extremely low while it's on site. We then looked at the overall likelihood of a release from an LNG fuel powered vehicle in the whole. It's therefore made up of a combination of the above, which leaves us to look at the following. So releases would initially be very cold temperatures, as we've already mentioned. However, the smaller volumes would rapidly warm up. Cryogenic burns or embrittlement would only occur if personnel or equipment were in close proximity to the LNG release. And the design of LNG vehicles is such that the most likely location of a release is from the primarily relief valve, which is typically located at roof level at the rear of the cab. And as such, personnel and equipment are really unlikely to be impacted by the release, and if exposed, are likely to only be exposed for a relatively short duration. So therefore, the actual likelihood of there being cryogenic injuries or damage from the LNG fuel systems at a particular site will depend on a number of factors, such as the number of LNG vehicles around, the amount of time they spend on site, and the amount of time personnel come in close proximity to the fuel systems themselves. Diesel-powered vehicles obviously don't present the same risks because obviously they're not impacted to the cryogenic nature. So we then looked at the comparative likelihoods. And given kind of the mitigation that we've said above regarding relief valves and all that kind of stuff and their location, whilst they are more likely to happen on an LNG vehicle, they're still relatively low likelihood. So they're still in a kind of the green severity, but a much lighter green than the diesel, which is at the far end where it's not credible. So we did this, we kind of alluded to the 13 various risks earlier on in the presentation. We did a very similar exercise to the one that we've gone through for each of those 13 scenarios for LNG. And we came up with a graph which looks something like this, where kind of we looked at powertrain sparks, and they're highly likely, the consequences are highly likely in both diesel and LNG, but the likelihood are kind of much further down the scale in the green section. If you look at the rupture of the fuel storage on there, which is line 5, you'll see that we felt that the consequences are much higher in risk than diesel. And there are several of those on there as well. You can see from high pressure releases as well that the consequences are more likely, as are the likelihood. But again, still relatively low down the grid in the green sections. Again, there are the other 6 scenarios that we discussed earlier on. Interesting to note that in some of them, the likelihood and consequences are less in LNG. If you look at the bottom line on there, obviously powertrain runaway, extremely unlikely to happen in LNG vehicles. Whereas with diesel, if obviously they get some air in there, which is what the tailwind valves and spark arresters are there to mitigate against, there is still some likelihood of a powertrain runaway. So diesel is further along the consequence and likelihood chain than LNG, although predominantly they're kind of in the same kind of scenarios or slightly the other way. Some important notes on site risk. Obviously, some comparative risks have been identified as being higher for alternative fuel vehicles than diesel, and some lower, which is I mentioned earlier on. But the actual impact between sites will differ, again, depending on the products that they store on site. I mentioned this earlier on. For a complex facility such as a refinery, we'll see lots of hazards and lots of different products. But for distributors, terminal or something like that, we may only see diesel and gas oil being stored on site, which is relatively low hazard. The key takeaway from this, though, it is important to use this risk information in guidance to support a site-specific risk assessment to consider the specific circumstances on the actual site in question. Really important that don't just use this document, use it in association with your specific site to produce that SSRA, which is really, really important. And the assessment should also identify effective risk reduction measures to ensure that the risks associated with the use of alternative fuel vehicles are kept alow, i.e. as low as reasonably practical. That is really important as well. So as I mentioned, kind of phase two, we kind of developed this document a little bit further. We looked at LNG, CNG, LPG and hydrogen combustion. And we use that to produce a risk matrix for each type, which I'll move on to in a minute, and obviously look at key risk reduction measures. And that really is what the risk matrix looks like. So there you can see basically the 13 scenarios that I mentioned on the right-hand side. And then we kind of categorized them so that powertrain sparks would be item 1, LNG being 1L, and diesel being 1D. And if you look on the risk matrix on the left-hand side towards the top there, you'll see 1D and 1L in the yellow sector of the risk matrix. There are some obviously that are in the green sectors towards the bottom. And then you'll see obviously in there in the risk matrix, if you look at item 13L, which is powertrain runaway, you'll see that in the bottom left-hand corner in the green section, because it's highly unlikely and the consequences are very low. But 13D, as we mentioned earlier, it's moving up at kind of 45 degrees into the yellow section. You'll see 13D. So we've kind of put all of those various things together into a risk matrix, which is slightly easier to view. Key risk reduction measures, which I mentioned about. These will be identified to support the sites in reducing their risk. And obviously they are hierarchical. So it's a case of looking to eliminate the risks where possible. If you can't eliminate them, prevent them. If you can't prevent them, control them. And if you can't control them, mitigate them. And this is fundamental, really. This is fundamental health and safety on a hazardous environment. So if we look at eliminating to start with, technical measures that eliminate a hazardous stage in the process or substitute it with a less hazardous alternative. For example, preventing delivery vehicles from entering the hazardous areas. Not always practical, obviously, but restricting the hazardous activities on site, such as refueling or vehicle maintenance and repairs. Again, if you can't prevent the delivery vehicle from entering hazardous areas, maybe do it at a time where operations on the site are kind of downscaled. So maybe at evening time or that kind of time, or kind of less peak times in vehicle loading, or when there's not a receipt going into the facility or something like that. Or alternatively, look at using vehicle types which are less risky for the site-specific site. Again, going back to the risk matrix that we spoke about earlier. And then we talk about prevention. Obviously, if you can't eliminate, look at preventing them instead. So look at maybe reviewing and updating the hazardous areas and associated ATEX requirements, identifying and managing potential above and below ground enclosed spaces that could be impacted by various fuel releases. Obviously, diesel, if it was released, kind of stays at ground level, but other fuel trains here might be gaseous, might be more dense, maybe less dense, and it may be things like that that we need to look at. And then obviously look at identifying and managing potential water-filled areas that could be impacted by fuel releases as well. Things like lagoons on site and that kind of thing. And then we look on control measures. Control measures to ensure that the facility and the vehicles using the facility operate within the design envelope. So, for example, identify and understand the specific vehicle design entering the site. Talk to the manufacturers, talk to the contractors that are coming onto your site to make sure that you have a good understanding of the vehicle, and also to make sure that they have a good understanding of the site in question as well, and including their key control measures such as relief valves and that kind of thing. And then ensure that the vehicles and their control measures are being maintained. We mentioned earlier on about the safe load pass scheme that diesel vehicles currently adopt. Make sure that things like that, so that loading passes, maintenance documents are all up to date, and make sure that vehicle maintenance is up to date as well, and also the maintenance is carried out in line with manufacturer requirements. And then obviously manage vehicle access, such as via the safe load pass scheme, which obviously I mentioned a couple of moments ago. And then also things like carrying out vehicle spot checks, such as carrying out the red seal on LNG vehicles. The red seal is kind of a seal that is over the relief valve and stays in place. It should be in place before that vehicle comes onto site. Manage the location and the layout of the parked vehicles away from drains, away from canopies where kind of vapors can collect, or obviously where product can drop down into drains that aren't necessarily part of a site's containment facility. Ensure the correct PPE. Obviously, we use certain PPE for diesel vehicles, but that PPE may need to be modified and adjusted for things like LNG, where there's cryogenic kind of capabilities as well. And also ensure that the staff on your site, and also the staff that are coming onto your site, are competent and trained and know what they're now dealing with these different powertrains. And finally, mitigation, obviously measures which can reduce the consequences of the hazard: gas, fire detection, vapor detection. Make sure your evacuation arrangements are correct. Firefighting plans are also updated. And also not only your own firefighting plans, make sure that fire response personnel that are coming on, so kind of fire and rescue authorities, are also aware that there may be a change to your facilities as well. So you're not just using diesel vehicles on site now, you're using other alternative powertrains as well. And also make sure that your first aid provisions on the site are obviously updated accordingly in association with the new powertrains as well. So phase 3 kind of replicates phase 2. The only difference this time is that obviously we looked at the electric vehicles, hybrid vehicles, petrol vehicles, and hydrogen fuel cells as well, as they become more prevalent in the market. Last slide from me is really, where can I find these documents? Obviously the presentation will be going out, or this has been recorded, and these will all go out as well at the same time. Please feel free to download them. If you're a member, obviously they will be at a reduced or free rate, but non-members can also download these documents as well. And I would urge you, kind of download phase 1 to start with, and then maybe you'll only need phase 2 or phase 3 depending on what powertrains that you are using on your facility. That's it from me, so I'll stop sharing, but obviously I'd be delighted to take any questions as and when they arise.
Thank you very much, Jamie. So yeah, as you said, feel free to post any questions in the chat or in the Q&A function. So we've got one already saying that you mentioned that this does not include peripheral equipment such as reversing cameras. Is there currently any guidance addressing the risk of peripheral equipment?
That's a really good and timely question, actually, because yes, there is. One of my other committees, the Road Tanker Panel, are currently putting together a very useful document which addresses all sorts of advanced driving aids that are put onto vehicles. And it's in the form of a risk assessment. It's very much a tick box exercise that you kind of answer the first question, and if the answer is yes, it's kind of a decision tree, which allows you to make the relevant decisions as to whether you need to make any adjustments to the vehicle. So a really useful document, look out for it. I envisage it should be due to be published round about October of this year, but again, it's a really good document and well worth a view.
Great. So there's another question about the applicability of this document internationally. Would you say this is more UK or European centric, or would
No, global. I mean, every facility encounters the same hazards. I mentioned obviously that it was a temperate, that a lot of the work was done around a temperate climate, but the same risks occur wherever. It was only because we needed some sort of groundwork to base this on. So no, most definitely not. I would urge anybody around the world to kind of look at this document. I think it's a really important piece of work for hazardous facilities with alternative powertrains.
Great. We haven't got any more questions coming in right now, but we'll give everyone a couple more minutes. Yeah, I'll just talk about these webinars. So while we're waiting for questions, so I didn't mention this at the beginning, but this is part of a technical webinar series. So we've had a couple of webinars earlier on this year on hydrogen and on a few other guidance that the EI produces. These webinars happen every month, sometimes 2 times a month, and you can all find them on the EI YouTube page. So we do have a question that's just come in. So which organizations are dealing with the off-site risks of these alternative powertrains?
Site risk really should be down to the vehicle manufacturers and the vehicle operators. As I say, I mean, this document itself only really covers the on-site risks, but there is stuff in there that can certainly be used off-site as well. But again, the vehicle manufacturers and the vehicle operators should really be talking to each other before any orders are made by the operator to the manufacturer to make sure that the design of the vehicle is really what the operator is looking for.
Great, thank you. I hope that answered your question. We got any more coming in? Feel free to put them in the chat or the Q&A. We'll give everyone a minute. If not, you can contact me with any questions after this webinar takes place, or as I mentioned earlier, if you're a member of the Energy Institute, you can go on EI Together and talk more about what you've heard of in this webinar. Any more questions? Maybe give it till 1:33, and then if not, we can close the webinar. Yeah, I hope you've all found this very insightful. Any closing words from you, Jamie, if we don't get any more questions?
Yeah, I'd just like to thank everybody for their time, and obviously the same, if anybody wanted to contact me on this specific piece of work, please feel free to do so. I'm sure Amy could provide you with my contact details, no problem at all. And for any members that wanted to join any of the committees, you're more than welcome to do so already if your organisation doesn't have representation on our committees.
Thank you very much, Jamie. So I'm not seeing any more questions, but that's okay. Yeah, so thank you everyone again for joining, and I hope you have a good rest of the afternoon. Thank you for attending.
Thanks everyone, bye-bye.